Continuing our work with quadratic equations in quadratic form, we have this problem in which we can see that we have a quadratic here, a square term here on this binomial, and that the binomial is repeated here as well. So we're going to use our u substitution method here, and we're going to let u represent the binomial t squared minus 21, and then u squared would of course be that binomial t squared minus 21 squared, which is exactly what we have represented in the original problem. So we're going to substitute in a u here and a u squared there. So we get 10u equals negative 24 minus u squared. And now this is a quadratic equation in u, and we need it in standard form, so we need a 0 on one side. We're going to let the 0 be on the right-hand side so that we can move over these two terms to the left and put them in the right order. So positive u squared plus 10u plus 24 equals 0. And this quadratic equation does factor. So u plus 6, u plus 4 equals 0. And so using the 0 property, we know 0 factor property, we know that u here would equal negative 6 or u would equal negative 4. And we're going to go back up and remind ourselves of what u represented. U was this binomial t squared minus 21. So we are not done yet. We have to go back here and substitute the t squared minus 21 in for the u so that we can solve for t, because the original problem was in t. So our final answer needs to be in t, right? Solving for t. So we're going to add 21 here, and we get t squared equals 15. And now we have a quadratic equation again. This time is in t, and it's a quadratic equation with no middle term. It says t squared equals 15. So we're going to use square root property. And when we use the square root property to solve for t, we're going to remember that we always take a plus or minus square root of both sides, right? So t equals plus or minus the square root of 15. And this radical doesn't simplify, so we're getting some irrational roots, aren't we, for this equation? Okay, and we're going to repeat the process over here on the right-hand side. So we're going to substitute t squared minus 21 for the u. Set that equal to negative 4 and solve for t squared, or t. Add 21 to both sides, and we get t squared equals 17. And again, we can use square root property to get t equals plus or minus square root of 17. So our four answers. So we ended up with 4 answers, and they are negative square root of 15, positive square root of 15, negative square root of 17, and positive square root of 17. So we are getting 4 irrational solutions. So similarly over here, now we're getting something that looks really complicated, but we're going to let you, we notice we've got this quantity here. We have it squared, and then we have a single. So we're going to let u be that whole big quantity, which is square root of 3t plus 8 minus a 15. So this is u squared plus 12u. And then let's add the 32 over and get a 0 on one side. And this factors u plus 8, u plus 4 equals 0. And using the 0 factor property, we know here that u is negative 8 or u is negative 4. Setting these to 0, solving for u. But now we're going to go back and replace this square root, this radical. 3t plus 8 minus 15 equals negative 8. Or square root of 3t plus 8 minus 15 equals negative 4, and we're going to solve for t. So we're going to isolate the radical, add the 15 over to both sides, because when we are solving radical equations, I will remind you, we isolate the radical first. So here we have a 7. 15 minus 8 is 7. And here we have the square root of 3t plus 8. And now we're going to square both sides to solve this radical equation. So here we have 3t plus 8, because squaring a square root, these are inverse operations, and they undo each other. And here we have a 49. So we're going to continue solving for t here, and subtract 8 from both sides. So 3t equals 41, and divide by 3. So we get this 41 thirds. We're going to have to check that. Okay, let's repeat the process over here. So again, add the 15 so that you can isolate the radical equations. You have to isolate the radical before you square both sides. Then square both sides. Right? And then squaring a square root. These are opposite operations, so they undo each other. And here we have a 121. And subtract 8. So we get 3t equals 113. And divide by 3. So I don't know about you, but I think we better check these using our calculator. Okay, so 41 thirds. I'm going to store that into x. And then I have square root. Let's figure out what this square root is. Square root of 3x plus 8 minus 15. So that number is negative 8. Okay. So then I have negative 8 squared plus 12 times negative 8, right? On the left-hand side. And I want to see if I get a negative 32. So let's see. Ah, so that checks. Okay. Okay, and so then now let's check the now let's check the 113 over 3. So now we're going to do 113 divided by 3. We're going to store that in x. And we're going to see what this big square root of 3x plus 8 minus 15. That is negative 4 this time. So the equation was negative 4 squared plus 12 times negative 4. And let's see if we get the negative 32. And we do. So those two fractions check.